So far, we've learned about how to graph functions in vertex form, where we just plotted the parent function and then shifted all the points according to these shifts. Today we're going to talk about how to graph functions in factored form. Again, you need 3 points in order to graph a quadratic function. And so the 3 points that we're going to use for factored form are the 2 solutions that come from each of the factors and the vertex. So first, you're going to plot the 2 solutions on the x-axis. These are the values that will make each factor be 0. So remember, the solutions are what makes each one 0, which is essentially end up going to be the opposite of these. So if this says plus 1, one of your solutions is going to be that, because -1 plus 1 would equal 0, and if this is 0, the whole thing is 0, which means y is 0. The other solution is going to be 3, 0, because 3 minus 3 would give you 0. So if you're not sure what these are, just set them each equal to 0, and then solve. So there's one solution. Set the other factor equal to 0. There's your other solution. Okay, so just set each factor equal to 0 and then solve that little mini equation, and that's going to give you what your 2 solutions are. It's very often just going to be the opposite of what's there. The only time that that's going to change is if you have a number in front of the x. Like if this said 2x minus 3, then you'd have to do this a little bit more certainly. But usually, if you notice, it's the opposite of what's in there. And that just comes from factored form, having the minuses in there. So we have the 2 solutions. That's 2 of our points. Let's go ahead and plot those. We have a solution right there, and then at 3, 0. So that's 2 of our 3 points. The third point is going to be the vertex. Now we know that since quadratic functions are symmetric, the vertex is going to be somewhere right in the middle. The axis of symmetry is going to be right along this line somewhere, because these 2 functions have to reflect over it on top of each other, which means they both have to be the same distance away. So I know that the x-coordinate of my vertex has to be 1, because that's going to put it on the axis of symmetry right in the middle of my 2 solutions. However, I don't know what the y value is. Where along? Is it up here at 1? Is it way down here at 1? Is it right there at 1? I don't know. So what I'm going to do is I'm going to take this value of x, I'm going to plug it into my function to see the y that goes with it. So f of 1 equals 1 plus 1 times 1 minus 3. So I just put my value of 1 is my x in for the 2 x's, and now I'm just going to solve. So 1 plus 1 is 2. 1 minus 3 is -2. So 2 times -2 is -4. So I know that my y value is going to be down there at -4. And then that is my function. So just to recap that, I found each of my solutions by setting each factor equal to 0 and then solving those little mini equations. Here I just had to subtract 1 from both sides. Here I had to add 3 to both sides. To get my 2 solutions, I plot them. And then I know that this is right in the middle of these 2. So I know that my x-coordinate has to be 1, because 1 is right in the middle of -1 and 3. And then I just plug that x value in to the function to get the y that goes with it, and I can plot that. That gives me my third point, and then I have my graph.